Video, I'm going to be talking about how to find the measures of exterior angles of a triangle. So for example, if we extend a side of a triangle, we've created an exterior angle. It's going to be a relationship between two of our interior angles that can give us the measurement of that exterior angle. It's called the exterior angle sum theorem. It says that if you just add up two of the interior angles, that will give you the measurement of the exterior angle. Specifically though, we want the two inside angles that are furthest away from our outside angle. Those are called remote interior angles. And by remote, we're thinking about the definition of something that's far away or distant, not like that controller you use for your TV. So remote interior angles would be the angles that are farthest away from your outside angle. Their sum is equal to the measure of the outside angle. So it does help to practice identifying those remote interior angles. So in the next example, we're going to do that. In this diagram, each of the sides of the triangle have been extended. So we've created three exterior angles. Angle 1 is exterior, and angles 6 and 4 are also exterior. So if we want to find the measure of angle 1, all we need to do is find our remote interior angles that correspond with that outside angle. So the two inside angles farthest away would be angles 5 and 3. If we add those measures together, it's equal to the measurement of angle 1. If we instead are looking to find the measure of angle 4, that outside angle, we'll look inside, and the two farthest away inside angles, angles 2 and 5, their sum would be equal to the measure of that outside angle. And one last time, let's just flip the question. 2 and 3, if I add those together, if they were remote interior angles, what would they correspond with? Well, they would correspond with 6, that outside angle. 2 and 3 are the farthest inside angles away from angle 6. So now that we can identify those remote interior angles, we can start to use them to set up equations to solve for unknown measures. In this first example, we know angle A and angle S here, 30 degrees and 42 degrees respectively. If we add those two angles together, that must be the same as the measurement of this outside angle, angle 2. So to find the measure of angle 2, we could just add 30 and 42 together and get our measure of 72. From there, we could solve for our adjacent angle 1 there. It's just a linear pair, so those two angles are going to create this line or add up to 180 degrees. So we could subtract what we know so far, 72, from 180 and get that interior angle measure. So hopefully you can see the relationship there that's occurring. To find angle 1, all we have to do is subtract these remote interior angles from 180. And to find angle 2, all we have to do is add those remote interior angles. So that's the reason why the exterior angle sum theorem works. Let's continue to practice using it. And this next example is a little bit more complicated. We don't have two interior angles. So let's try and, as a first step, find one of our interior angles. If we want to find the interior angle up here, well, we can use this linear pair relationship, subtract 145 from 180, and get the measure of 35 up there. And now because we have that interior angle and this expression representing this interior angle, we have two remote interior angles corresponding with this outside angle right here. So if we add these two measures together and combine like terms, we can set it equal to 60, and that'll allow us to solve for x. However, we could approach this differently. What if we instead wanted to solve for this interior angle measure? Again, we just have our linear pair relationship here. So 180 minus 60 would give us our unknown angle, 120. Now we have this interior angle and this interior angle right here. Those two would be remote interior angles to this exterior angle. So we could combine or add 120 and 36 and x together and know that it equals 145, and that equation would help us solve for x as well. There is also a third way, but it doesn't involve the exterior angle sum theorem. It involves the interior angle sum theorem. So if you know this inside angle, and this inside angle, then all three are going to add up to 180. So that's another way that we could have done it, but I just wanted to emphasize the exterior angle sum theorem in this video. Be careful whenever you solve for x. If you get a negative value, just double check that if you were to plug it in, you would still get a positive angle measure. All right, one last example here. This time we're going to solve for the measurement of angle NED. So first we're going to solve for x by using our exterior angle sum theorem. We know that these two angles are remote interior angles. Their sum is going to add up to and equal this exterior angle. So combine those like terms there and get 5x plus 40. Set it equal to your outside exterior angle. And now we can solve for x. I'm going to subtract 5x from both sides. So I'm moving my x's to the right side. If I do that, I'm going to want to use or move my numbers to the left side. So I'm going to add 8 to both sides. So my x's cancel over here, and I'm left with 4x on the right side. My 8's cancel on this side, and I'm left with 48 on the left side. One more step, divide by 4 to solve for x. And 4 goes into 48 12 times. So take that x value now and plug it into your expression representing the measure of angle NED. So we're going to do 9 times 12 minus 8, which is 108 minus 8, which gives us a final measurement of 100 degrees for that angle. So play around with the exterior angle sum theorem. Practice identifying those remote interior angles that correspond with another exterior angle. But don't forget about that interior angle sum theorem as well. Both theorems help us solve for unknown angles in any triangle.